Well, happy Friday. This is the first Geospatial 2.0 Friday talk for at least 2 months. Why? Well, partly vacation, partly just things have been changing. So I felt like it was time to take a little hiatus. But it's over and we're moving on. And today's our first Friday talk. And what I'm going to do today is actually reflect on Geospatial 2.0. In fact, what I've learned over the last 2 years, so a good chance to step back and just review and talk about where we've been on this journey. So for me, I started out really in the two-dimensional world. So GIS has been most of my career, and GIS has lived its life mostly in the two-dimensional world. And as I've got on the screen there, over there, look at that, I can point, map generation paradigm has been a core part of what GIS has been about. It's about presenting 2D maps to folks. And I became, when I started working in GIS, and most of my career was within the web mobile world. So I became a map maker, which as a geographer was a little bit, it wasn't part of the plan, but it was an interesting journey to start using this quite incredible software. So what came next? Well, three-dimensional data has been around for a long time. In fact, the AEC world, architects and those guys, they like working in the three-dimensional world. They learn these software packages and they work in the three-dimensional world. So a lot of those guys are familiar in that landscape. Lots of other people are not. So 3D is now much spoken about. It is the term digital twin you'll read a lot about. And frankly, I'm beginning to loathe the term because I see it all the time and it's still kind of poorly explained, poorly understood. So, but anyway, we've now got the availability of three-dimensional data. Four-dimensional data. We hear much about the Internet of Things, IoT. There's a huge push on 5G. That is the ability for sensors that are attached to dumb devices and smart things like us can actually transfer their data over the network into the internet and into databases ultimately. So this is in much case a real-time data feed, and we're about to get a tsunami, an enormous, incredible volume of data coming thanks to 5G. So the whole world of four dimensions is really attaching or at least having sensors which can push data back from static devices. That might be a thermometer in your house, and moving. That could be a car, that could be you moving around with your phone. So we now have these three very core data sets that are available to us: two dimensions, 3 dimensions, and 4 dimensions. So why is that important? I did some work a while ago from which these pictures are taken, which was really telling a story with data. So it was really a different approach to thinking about what data was. It was the first time I'd done it, and it was a really nice piece of work. So the focus was on, as I've got in the title, it was kind of approaching problems slightly differently without just thinking pure 2 dimensions and flat maps. It was a different story. So this work was actually focused on safety engineers in transportation departments. Now their workflow, as I learned, was the first thing they did was they got data from the police, and software was used to map the data. So they were used to looking at maps, which had lots of data on them. In that left-hand side, right above me here, is a classic 2-dimensional map. And by the way, all this I'm showing here was all presented in a web browser. So the real beauty of 2-dimensional data is patterns. We can put a lot of data in, and because we're wired to understand pictures, we can load those maps up with data and understand it. And in this particular case, this was collisions in a city. So these safety engineers were most concerned not so much about all the collisions, but much more those that were serious injuries and death, those type of collisions. So this left-hand diagram here shows heat maps and clustering. Again, a really nice way to not only very quickly see where the most collisions are in this city, and in this case it was mostly intersections, but also they could drill down with the data and look at the attributes and see what type of collision it was, what type of an injury was incurred, etc., etc. So it allows those engineers to understand and to isolate their focus on those places which are most problematic. Now, their end goal of these engineers was to actually to actually diagnose the problem and fix it. That might mean putting a roundabout in, that might make, any number of different things. After they'd understand where the most problematic areas they were in the city, the next stage was to drive out to the intersection and take a look. So they wanted to see if there was overhanging vegetation, broken guardrails, something about that intersection that was causing them to be a high number of, high injuries and deaths. So measurement was also an important part of that. So 3 dimensions, data-wise, gives those folks a sense of place. Now, what does that mean? It means they don't have to drive out to the intersection. They can actually look at that data in 3 dimensions. They can look from above, they can look from all angles, they can navigate around in that 3-dimensional world, and they can start seeing where some of those problems are. And by the way, since it's LiDAR data, they can do very accurate measurements in the browser. So massive time saver. And the other part of that is they can actually add additional data sets to what they're looking at in 3D. So you can load it up with, for example, point data where collisions occurred in the intersection from with GIS. In this case, we actually added 3-dimensional actual crash data to the intersection. So even though it's 3D, it's an additional data set that they wouldn't have seen had they been out in the field. And there's a whole slew of other data that we could have put in there. Now, the 4th dimension is change. So that means we can actually watch, or an engineer could watch traffic moving through that intersection. You'll see in that picture there are vehicles moving through the intersection. So they could watch that in real time. They could actually see recorded versions of it. They could see pedestrians in that area as well. So movement was something that's very important there. So what we've done there is really told a data story. We've gone from 2 dimensions, which is to see patterns, a narrow area of focus. We've provided 3 dimensions, which is a sense of place, as if we were standing on that street corner, but enriched with other data sets. And then the third piece is to see change, to actually monitor in real time what's actually happening, or see past movement through that intersection. So a really good piece of work. And again, it helped those traffic engineers understand, using data, how to diagnose problems. Okay, moving on. The other piece to the 2.0, the Geospatial 2.0 story, was the recognition by me and others that have focused on 2.0 on the fact that we now have new data and new analytics. And that's been really quite recent, in the last 2 or 3 years. So what are those pieces that we're talking about here? Well, above me, you'll see new sensors. And I'm really talking there about the Internet of Things. We hear a lot about the Internet of Things, but we're now, our phones are sensors. We can track one another moving around. We can track vehicles moving, supply chain. We can see where and when things might arrive in port, or on rail or road. There's a health piece here. We can track people who may be moving out who've got COVID. Millions of things we can now track, and again, 5G will enable that as that rolls out. So we have brand new miniaturized sensors collecting data. We've also, there's a lot of noise in the space, the Earth observation being sort of the term that's used. So that's really primarily the focus is on, it's not exclusively this, but it's mostly satellites. So things are in orbit. So we're now putting up, as they call them, new constellations, which are not only taking imagery of the ground, but also using SAR radar, for example. Complex technology, but the advantage of SAR is clouds don't get in the way, like with an image, and you can continue working at night and collecting data at night. So we've got this whole new source of data that's now coming online from Earth observation. And if you've ever bumped into Joe Morrison, he talks a lot about that particular area. So that's 2. Number 3 is 3-dimensional data, and we're really talking about LiDAR here. We've now got LiDAR that's being collected at all levels. So we've got it from the air, we've got it from so planes, drones. We've now got terrestrial LiDAR as well, so we can actually drive down a road and we can collect data as we're driving along of that road. So transportation departments use that a lot. We can walk in forests like that picture showing, and see the 3-dimensional version of what that forest is. And we can go inside of buildings, and we can now start collecting data inside of a building. So there's handheld devices, there's things on tripods, there's things that are flown. And remember, Apple's new iPhone has now got LiDAR built in. So we're now going to get again, I keep using that word tsunami, but massive amounts of location-based data. So with that huge collection of data that we're now collecting, and it's only going to get bigger over time, how do we process and analyze that data? The old paradigm, which is where we have an analyst in the middle, is going to be slowly but surely going away. That doesn't take the expert out of the conversation, but it does take some of the grunt work out of what they need to do in terms of data processing, data cleaning, and some degree of analytics as well. And that's where artificial intelligence and machine learning come in. Now, there's a lot spoken about them. They're very new, too much hype actually, but over time, we'll see a lot more use of AI within these data sets that we're talking about here. So new analytical tools. So that's the second key part of the conversation. The third key part, which is relatively new and actually relates to some news on my side that I've actually just joined Critigen, who are experts in this area, is geo-enablement. So geo-enablement really, and we'll split that diagram down in half above me. So this piece to the left here, as I'm pointing, is really the location data piece. And any of those data sets we were just talking about would fall into this category. This diagram is more sort of GIS centric, but the idea is we've got things, people and things that have a location, stationary or moving, have attributes as well. And we are actually then connecting those in or linking those into business systems that don't have geolocation built in. So let's use the example of a work order. A work order, somebody gets sent out to fix something. That work order is actually sitting in an SAP system, for example, or Maximo, or any other big business system, linking that to where that person is in the field and actually using the location as almost the key that links all these pieces together really enables that process. So you can imagine these big business systems being linked into location-based systems such as GIS. The world of possibilities of solving problems and answering new sets of questions are vast. So geo-enablement is an important part of the 2.0 conversation and will really start to help bring the location data and location analytics into the business world, a community that really hasn't been touched greatly by the existing geospatial world. And I'm talking about GIS, I'm talking about remote sensing, others that work in that field. So this is going to be a real game changer. So let's pull all that together in one last diagram. My head's in the way of geo-enablement. It looks a complicated diagram, but all I've done is taken all the pictures I've shown you and added one more. So pulling Geospatial 2.0 together, it's a data conversation, new data sets that we've now, multi-dimensional data. It's the story of new analytics, AI, machine learning, algorithms that can process that data and analyze that data. It's a story of geo-enablement where we link location-based data and systems into business systems to geo-enable them. The outcome ultimately of Geospatial 2.0, though it's still importantly a technology conversation, is improved business outcomes, like I show on the extreme end of the diagram there with the bullseye. So, improved business outcomes is the ultimate goal here, is to actually deliver and be able to answer questions more efficiently, more effectively, and more accurately as well. So that's the Geospatial 2.0 story. I thought it worthwhile today just to walk through that. It's a slightly longer video than I like to do. But as we move forward, we'll be exploring ever more these areas of evolution of our industry. So thanks for watching, and have a lovely weekend. And I'll do this again next week. Thank you.